Curvilinear coordinate systems 8. Derive the HIs, the scale factors, for the cylindrical and spherical systems. Also derive the expressions for the gradient, divergence, and curl operators in these systems. Alright, so first we will deal with the cylindrical system. We start out by writing the position vector r in Cartesian coordinates. This is x ex hat plus y ey hat plus z ez hat. And the transformation between cylindrical and Cartesian coordinates, x is equal to rho cosine phi, and we have ex hat. Y is equal to rho sine phi, ey hat, and then we have the same z in cylindrical coordinates, z ez hat. Now what we need to do is take a derivative of the position vector, del r, del rho, for the rho coordinate, and this will give us cosine phi ex hat plus sine phi ey hat. Cosine phi ex hat plus sine phi ey hat. And the magnitude of this vector, del r del rho, gives us the scale factor h sub rho. So this is the magnitude of del r del rho. And we can see that we have square root of sine square phi plus cosine square phi, which is 1. So the scale factor must be 1. So we have our first answer, h rho is equal to 1. And now we can work on h theta. We need to take a derivative of the position vector with respect to theta, del r del phi, not theta. This is going to give us minus rho sine phi and plus rho cosine phi. So minus rho sine phi ex hat plus rho cosine phi ey hat. Then we need to take its magnitude. The scale factor for phi, h phi, is the magnitude of del r del phi which is equal to rho times square root sine square plus cosine square. Sine square phi plus cosine square phi square root, which is equal to 1. Therefore, we have the scale factor h sub phi is equal to rho. And finally, we can work on the scale factor for z, but that must be equal to 1 because z is the same in Cartesian and cylindrical coordinates. Anyway, so if I do it formally, del r del z is equal to ez hat, which tells me that the scale factor magnitude of del r del z must be equal to 1. So that completes the scale factors for the cylindrical coordinate system. Hz is equal to 1. Okay, as for the gradient operator, the gradient operation in curvilinear coordinates is qi hat over hi del del qi. So in this case, we're going to have, if we apply this to cylindrical coordinates, the gradient operator is going to become E rho hat over H rho del del rho plus E phi hat over H phi del del phi, and then we will have EZ hat over HZ del del Z. So if I apply this to what I have found for the scale factors, the gradient operator in cylindrical coordinates is going to become E rho hat. Now H rho is equal to 1. That's what we have found here. Therefore, this is just E rho hat del del rho. And then I have E phi hat, the scale factor H phi. H phi we have found to be equal to rho. So if E phi hat divided by, so let's write it this way. E phi hat 1 over rho del del phi. And then we have EZ hat del del Z. This is the gradient operator in cylindrical coordinate system. Now, as for the divergence, we have to do 1 over h rho h phi hc. The derivative with respect to rho h phi hz a rho plus derivative with respect to phi h rho hz h phi, derivative with respect to z h rho h phi az. So that's the divergence. Now, if I apply it here, I'm going to get divergence of a vector A written in cylindrical coordinates. Divergence of A is the product of the scale factors is 1 rho 1, so that's 1 over rho, 1 over rho. So the product of the scale factors h phi hc, that's rho times 1, that's rho. So we have del rho a rho del rho. And then we have again 1 over rho, which is the product of the scale factors, 1 over the product of the scale factors. H rho hz is 1, so this is going to be del a phi del phi. And the last term, we have h rho h phi, which gives us a rho here, and we also have a 1 over rho, so the rho's will cancel because there's no z derivative of the rho. So the last term is simply del a z del z. The 1 over rho prefactor has been cancelled by the rho that appears in this product. So this is the answer for divergence of A. Now the curl operation can be written in using subscript summation notation epsilon ijk qj hat. So this is basically the curl operation, divided by hj hk del del qj hk ak. But in practice, what we are doing here is, so this is easier to remember, the curl operation is given by this determinant. So we have, similar to divergence, 1 over the product of the scale factors h rho, h phi, and hz. And then we have to take this determinant. So instead of e rho hat, we're going to write h rho e rho hat. And then we have h phi e phi hat. And then we have hz ez hat. Del del rho, del del phi, del del z. And then we have h rho a rho, h phi a phi, and hz a z. So it's given by this determinant. Okay, so if I apply this procedure here, I'm going to get 1 over the product of the scale factors is 1 over rho. Then I have h rho, which is 1 e rho hat. So the first term is e rho hat. H phi was rho, so this is rho e phi hat. And then I have hz, which is 1. So hz is 1, so I just get ez hat. Del del rho, del del phi, and del del z. That's what I obtain here. And the last term, h rho a rho, that's simply a rho. H phi a phi, that's rho times a phi. Hz az is simply a z. So we have to take this determinant. Okay, so we can write curl A let's move this up a little bit. So we can write curl A is equal to 1 over rho prefactor. And we're going to evaluate this determinant with respect to the first row, so plus minus plus. So first I have e rho hat times del az del phi minus del del phi of az minus del del z of rho a phi. So I have del az del phi minus del del z of rho a phi, and this is going to be in e rho hat direction, the first term. The second term, I'm going to get del az del rho, but because of the minus sign, it will be minus del az del rho and plus del del z a rho. And then I have a rho and 1 over rho, so they will cancel out. So I will obtain del a rho del z minus del az del rho in E phi hat direction. And the last term, I cross the first row and last column, del rho of rho a phi minus del phi of a rho. And there's the 1 over rho prefactor. So plus 1 over rho del rho of rho a phi, and then I'm going to get a minus del a rho del phi in ez hat direction. Okay, now I notice that here I have a z derivative and rho doesn't have a z derivative, so that will come out. So I can write curl A as 1 over rho del az del phi, because the rows will cancel here, I'm going to get minus del a phi del z in e rho hat direction. That's the first one. The second term is the same, plus del a rho del z minus del az del rho e phi hat. So let's copy this. This is the same term. The last one, I have 1 over rho del rho a phi del rho minus 1 over rho del a rho. Let's do this so we can move this up a little bit. Then I'm going to get del rho a phi del rho minus 1 over rho del a rho del phi, and this will be in ez hat direction. And that's the final answer for the curl of A written in cylindrical coordinates. Okay, so for this first part here, first I evaluated the scale factors by writing the position vector in Cartesian coordinates, doing the transformations from cylindrical to Cartesian coordinates, taking derivatives with respect to rho, phi, and z, and taking the magnitudes. I've obtained the scale factors 1, rho, 1. Gradient operation is qi hat over hi del qi in curvilinear coordinates. So it is e rho hat 1 divided by 1 del rho, e phi hat divided by rho del phi, because h phi is rho, and then ez hat del z. Divergence is 1 over the product of scale factors del rho h phi hz a rho plus del phi h rho hz a phi plus del z h rho h phi a z, etc. So substituting the scale factors here, the first term is 1 over rho del rho a rho. The second term doesn't have any rho here because these are both 1. So I have 1 over rho del phi. And this one, however, has a rho in it, but the z derivative of rho is doesn't exist, so the rho just comes out and 1 over rho cancels out. I obtain del AZ over del Z. The curl operation is performed by taking this determinant, so I have to consider 1 over product of the scale factors h rho e rho hat, h phi e phi hat, h c e z hat, e rho hat, rho e phi hat, e z hat, partial derivatives, the vector components multiplied by corresponding scale factors, so I only have rho a phi here. And the curl operation was performed with respect to the first row, e rho hat times del az del rho, del phi minus del z of rho a phi in e rho hat direction. And in this case, I don't have a z derivative of the rho, so the second term, rho's will cancel, and this will actually become minus del a phi del z e rho hat. The other two terms, because of the minus sign here, I'm going to do this one first, del a rho del z minus del rho of az multiplied by rho e phi hat, but rho divided by 1 over rho divided by rho, I have e phi hat, and the last term del rho a phi minus del phi a rho, and there is no cancellation of rho here because this has a rho derivative, and here I don't have any rho in the prefactor. So I obtain this final answer for the curl in cylindrical coordinates.